This audio abstract was created and produced by Arcadis. All statements, opinions, interpretations, and conclusions expressed belong to the individual speakers and do not represent views or policies of the Groundwater Monitoring and Remediation Journal, Wiley Publishing, Arcadis, or any other entities. The methods for collecting, analyzing, and displaying data have changed over time. However, the underlying goal for visualizing data has not, clearly communicating complex data for ease of interpretation. New data visualization tools can better leverage the larger and more diverse data sets that are now increasingly common on remediation projects. For example, dashboards allow analytes and date ranges to be selected for a graph and are particularly useful for understanding the performance of remediation systems. Therefore, they can greatly aid in optimizing system performance. The larger quantity of available data and new visualization methods can make conveying results significantly easier. However, they also introduce new problems that can lead to confusing or misleading results. The purpose of this article is to share a variety of practical tools and techniques to aid in creating successful data visualizations, specifically for site characterization and remediation information. I've asked my co-author, Mr. Zach Wahl, to help summarize some of the main features and recommendations of this article. Zach, thanks for joining me today. To start off, can you provide a bit of your professional background and describe your interest in new tools for data display and communication?
Yeah, thanks, Craig. It's great to be here. My name is Zach Wahl. I'm an environmental engineer with a little over 8 years of experience in all things remediation, high-resolution site characterization, emerging contaminants, things of that nature. And I've also always had a interest in the design thinking process and things of that nature. And that's why I've been very interested in different ways of effectively presenting information. Right from an engineering background, we do lots of calculations and investigations, and it doesn't matter if you don't present it effectively. So I've always been interested in the different tools that are out there and processes that we can use to do that effectively.
You mentioned this term design thinking, and I think it's an interesting concept to apply that in the context of data visualization. Let's dig into that a little bit. What is design thinking, and what are some of the major tenets that are applicable in this case?
Yeah, so design thinking itself, it's a standardized process for coming up with creative solutions to different problems. And a lot of it's centered on really thinking through who your audience is. So, right, it's these 5 steps of empathize, define, ideate, prototype, and test. Typically, it's used when you have really, really big problems, but there are a lot of elements that are really applicable to this process of coming up with visualizations itself, because, right, each of these is, we're coming up with some solution of answering the problem of how do we effectively display this data. So there's these 5 steps, right? And the biggest and most important one is this empathize factor, which is where you really try and get in the head of who your audience is going to be, right? Who am I presenting this data to? Who is this having this problem that I'm trying to solve? And then, right, going into that definition step, which is, right, what specifically I'm trying to solve. And when that comes to visualizations, it's what question am I trying to answer? It's pretty typical to, right, do a prototype test. And this is, I think, very applicable to data visualization as well. Because, particularly if you're going to spend a bunch of time coming up with a figure that might not be quite right in the end, it's a lot easier to come up with the prototype. And, typically we used to sketch it out on a whiteboard, but now you can mock it up in, a simple, like a PowerPoint, or you can sketch it out on your computer screen as well.
So in the article, after we talk about design thinking, we present some general concepts and recommendations, and I would think of them sort of as rules of thumb for figure creation.
Right. It was a good exercise to compile all these different sort of practical tips when putting these figures together. Right. I think a lot, right, as you mentioned, are intuitive, but some maybe not as much. And definitely helpful to see them all listed together. But right, the main thing is, when you're creating a data visualization, most of the time you're not there to explain it. So, it needs to be something that is easily interpreted, effectively presents the data, and has everything you need there. But yeah, the big thing, right, is you want as much as possible to simplify. You don't. There's a lot of different tools out there for making things look pretty or flashy. Like 3D graphics on text, or sorry, 3D graphics on text, or on some of your graph features. Things of that nature that can distract from the data itself.
Yeah, I think you're really onto something with that theme of simplify. There's, I guess, almost an axiom that you could take away, that if an element doesn't contribute, it takes away from the impact or the compositional strength.
I think we both mentioned simple as a good thing, right? We want to remove any barriers or challenges that the audience or the end user might have when interpreting the data, and a lot of that can come from simplifying and decluttering some of the visualizations. So some very simple things that are easy to apply and can make a big impact to showcasing the data itself, right? Removing borders around graphs, getting rid of background colors, on visualizations. As I mentioned, removing some of those artistic effects, like adding shadows or text effects if they're not adding any value. There's stuff like, you can consider making some of the axes, a lighter color to allow the attention to go towards the data itself.
Yeah, ease of digestion. And I think there's a lot of sort of standard template type things that we do that we don't, because they're standard, we don't think about them. We just simply apply them, and kind of stepping back and looking at all the elements of a figure and really thinking about, is it necessary, and what's the way to maximize the information transfer rate and the ease of interpretation.
Yeah. What barriers can we remove? Something, again, going back to that, design thinking principles we outlined earlier. If you were trying to go through that process of understanding exactly what you said, what's the first thing they're going to ask, or the first thing they're going to do to try and, make sense of that data themselves, and make those changes, so the end user, the audience member, doesn't have to.
You started to touch on large data sets, and I think increasingly practitioners are managing really large data sets, and there's some challenges related to decisions about how much of that data to display and how to display it, and whether there should be any sort of pre-processing. Could you provide some thoughts on data density and taking advantage of all that data, and yet still maintaining simple and easy to understand graphic approaches?
I think definitely something that we're all starting to run into. We have access to a lot more data, and whether that's new types of data, whether looking at new analytes, or new tools reporting new types of data, in addition to just a lot higher frequency. With some of the digital collection tools that are out there, we're getting incredibly high readings from sensors, and even just collecting field data digitally. We're seeing a lot more of that data tabulated and enabled for us to visualize if we so choose. And that's really that first important part, right? Is how do we choose which of those data sources and types are necessary, and benefit the end goal of what that visualization is trying to accomplish. So need to include what's necessary, and make sure that we're not selectively leaving out data that could skew the results.
Yeah, I think there's a data curation step where you're looking through and the existing data set, and recognizing, kind of high grading out the high value data, and then of course displaying it in a way that is digestible. But there's some responsibility when you're doing that you are taking care to show all of the important data, and that the potential for misinterpretation certainly is eliminated. There are new tools that can help here are the class of tools that allow the user to interact with the data can be used effectively to this end, because you can prescribe an initial view or presentation of that data in sort of a curated way, where what you as the figure creator think is important is displayed, and yet the user has access to all of the data, or has the ability to manipulate the view to see that data in ways that they want to look at it. So maybe you can provide some thoughts on how do we better leverage these kind of interactive tools, particularly in the context of large data sets, in the remediation space.
Yeah, these new interactive tools we have definitely add a lot of opportunity with some of the dashboarding tools that are out there now. You can go through the effort to create one dashboard and you can see every single location, which that provides a lot of value and it gives you a lot of opportunity. But on the other end of the spectrum, it might potentially make it so it's a little overwhelming, a little too much data to look at all at once. And right, similarly, with some of these other interactive tools, for instance, the like 3D modeling of sites, that's something that itself just provides a lot more of an immediate understanding. I think we can all relate to in the past looking at, for instance, a cross-sectional drawing of site geology, and you have to go through that mental hoop of, all right, I'm looking at the plan view figure, I can see where the cross sections are. Now I'm looking at this other figure and trying to put all of it together in 3D space. Whereas some of these interactive 3D models, you can there's no explanation needed. You don't have to go through that extra set of gymnastics. I think technical and non-technical folks have an ability to understand that, which is incredibly useful. But as you also mentioned, these interactive tools are great, but they can be overwhelming because they're the possibilities are endless. It's up to you to play around with it and look at the views you want to, click on the different sets of data that you want to see. That's where it gets really important to do that sort of first step and really think about what the who your audience is and what you want to share with them. And a lot of these tools have options where you can build in these preset views, with whether that's in a 3D model looking at a specific angle and a certain set of data, or for a dashboard, having certain preset combinations of charts, and that way you can still tell that defined story, as folks can look through these preset views, but it also gives them the opportunity to interact with the data themselves and confirm or make their own observations.
So we talk about photography a bit. It's one of the simplest and most common methods for communicating information. And of course, it's been around a long time. But, with the advent and ubiquity of mobile phones and tablets, they are now increasingly being used to document data and conditions in the field. Things like sample locations, site settings, field methods, or unusual conditions. Let's talk a little bit about practical techniques that can be used to strengthen the composition and effectiveness of photographs, particularly in the context of remediation projects.
As you mentioned, phones are standard at this point. Phones or tablets. Everyone has access to a pretty high quality camera. And because this is so easy to take photos now, it can, if you're not careful, lead to too much clutter, right? A picture's worth 1,000 words, but, you need to think about what those words are. Otherwise it can get sort of lost in the noise.
I think the design thinking principle applies here. And honestly, really what it boils down to in a lot of cases, just simply slowing down and thinking about what is it you're actually trying to photograph and communicate. And when you do that, it's pretty easy to think about, okay, are the things in the frame that are unnecessary or take away? Is the background cluttered? Am I really zoomed in on the subject matter of interest? Do I have the right angle? Are there things that provide the appropriate context, like, something that shows scale? So I think, slowing down is sort of the first step. And then I think, there are a number of sort of compositional rules of thumb that I would say a lot of engineers and scientists are unaware of, but are easy to apply once you know them. So, Zach, this has been a great conversation. Let's wrap up with a look forward and some closing thoughts. I mean, where do you think we're headed with data visualization?
Yeah, it's been interesting, the sort of transition that data visualization as a whole, as well as in our industry, has changed. We've gone from hand drawn drawings, which I think we are all familiar with. Some of the old geologic cross sections, and I think we found a couple ourselves when we were looking into example figures for this. They advanced capabilities to where we were able to generate a lot of these with computer generated graphics, and then have moved into this sort of new era of the data being interactive, whether the audience is ourselves looking at our own data, or whether presenting that data to other stakeholders. I think as folks have gotten a taste of these sort of interactive options, I think the expectation is that those tools are only going to expand. It's a lot more effective, and I think people are interested in being able to interact with their data, as long as, again, that those preset views are there to guide people towards the end goal that you're trying to display there. So I think those interactive options are going to continue to expand, particularly as people continue to get access to more powerful tools and smartphones, and sort of have the ability to interact with that data.
Great thoughts, Zach. Thanks for helping pull this article together. I think it'll be something that folks will find a lot of use, and it's an interesting one to read. Thanks again for your time.
Thanks, Craig.